Hi, my name is Brandon, and today we're going to be building the Breaking Wind, a pistol-sized springer that utilizes spring thunder shells. The Breaking Wind was developed by CYardNerf, who are also the creators of the Second Wind sort of Big Shock retrofit that came out a little while back. However, whereas the Second Wind was a modification for an existing blaster, this is a completely built from the ground up 3D printed blaster. And while it requires some very specific hardware that's not exactly standard across other 3D printed blasters that you might have on hand, it's a very simple build. If you're interested in more builds like this, feel free to subscribe, but for now, let's get into it. All right, we have all of our parts laid out. I will start with the 3D printed pieces and then move on to the hardware list. The trigger, catch, T-pole, bottom plate, shell carrier, and plunger were all printed at about 80% infill because I'm concerned about the reliability of those parts since they're directly going to be pulled on or have force subjected upon them. At the very least, I would recommend printing your plunger a little thicker than usual. Everything else is at about 20% infill, and this is all PLA. Now on the hardware side, this list gets a little exhaustive, so in the description box below, I will have a full list of the parts. However, when you purchase the file set, you should also receive a bill of materials outlining these as well. First off, we have 7 440 screws, 3 that are about a 1/4 inch long, and 4 that are about 1/8 of an inch long. You will also need segments of 0.041 inch diameter music wire. You need at least a 2-inch segment and a 1.5 inch segment. However, you can also have 2 1/2-inch-ish pieces of music wire to help hold on your trigger guard. That is completely optional. However, when you buy music wire, you're going to end up with a lot more than you need, so you may as well. You will also need at least 4 finishing nails, and you need to, at the very least, remove the head of the nail. There's a few places where you could technically leave the head on, but really it's just going to get in your way. You will also need 2 1/4 20 nuts, as well as 1 5-inch long 1/4 20 bolt, 4 6/32 acorn nuts, and 2 6/32 threaded rods. I had some difficulty locating these rods. I was ultimately able to find them at Lowe's. Ace Hardware also carries them, however all of the stores in my area were completely out of stock because of some strange threaded rod shortage that I was not aware of. You will need 2 O-rings. Standard sizes are 112 and 123. A 3 7/8 of an inch length of polycarbonate tubing that is 1.5 inches in diameter and has a 1/16 of an inch inner wall. A small piece of EVA craft foam or rubber. You will need 6 disc magnets that are 0.315 inches in diameter and 0.118 inches in depth. And finally, you will need a spring. I was told by the creator that the intended spring for the system is actually the K25 for a Talon claw, provided by Silver Fox Industries. However, I don't have one of those, so I'm going to be using a cut-down version of a standard K25 that you would see in a Caliburn or one of Slug's Talon claws. If it ends up being too strong or there's too much compression, then I'll just cut a few coils off. And of course, you will need a screwdriver. However, you will also need some sort of pliers as we will be bending this music wire, and a hot glue gun. So I'm actually going to start with the wire so we can just kind of get that ready and out of the way. I'm going to be doing this on a cutting board so I don't damage my workspace surface any more than it is already damaged, as this is cheap plywood and this is pretty hard. So with your shortest segment of music wire, we're going to be bending it at about a 45-degree angle, directly in half, or as close to it as you can get. There we go. And the longer one gets tricky, because we're actually going to make 2 bends. But first, we're going to bend it directly in the middle, also at a 45-degree angle. Like that. And then we're going to take about 1/8 of an inch of one of these lengths, and you want to bend it at a 90-degree angle perpendicular to this bend. So you want, basically, if this is laying flat, this is going to be coming straight up. Like that. So now we're going to take our grip and our trigger and the longer, weirdly shaped spring, And basically the spring is going to rest inside the trigger like this, and we're going to be hooking this small little bit sticking out into a hole that's about right here on the left side of the grip. It's impossible to see on the camera, but you'll be able to see it on your own. And the way we're going to do that is by setting the trigger in place and trying to line up this hole with this one, and then sliding one of our finishing nails into this hole to lock it in place. I actually cut this one down a tiny bit more because it was sticking out. That's entirely up to you. I would recommend cutting off the sharp part if it's going to be sticking out for obvious reasons. And be careful if this is a little bit too loose while you're working on this, it might tip and fall out. There should be enough force kind of between these parts to hold it in place, but just be aware that it might slide. And then we're going to take this and kind of push it into place. And then what you're going to want to try to do is push this in so that it gets into that little hole. I would really recommend doing this with pliers. And see, I'm going to kind of slide it into that slot. And be very careful, this is under a lot of pressure. You should always wear eye protection, but in particular, keep this angled away from your face while you're working on it because it is extremely dangerous. And then take your polycarbonate tubing and put it in at kind of an angle so that it gets under this lip right here. And then once it's in, just push it down as far as it goes. And that should hold that in place. Make sure that your trigger pulls. Perfect. Now there should absolutely be enough pressure that this nail is not going anywhere. So we're going to set that aside, and we're going to take the main body. Now, I printed this in draft quality because this is more of a prototype build for me. My surface finish is terrible, and my paint is even worse than usual, so overlook that. These bands are not in the actual print, they are just on mine. But what we're going to be working on is this catch down here. So we're going to take your shorter spring segment, and see it's going to slide right into this groove here. And on this catch, you'll see that there's a little notch here for the other side of the spring. So try to align it with that little groove. And then once you kind of have it in place, take another finishing nail, and you're going to slide it right through here, through the catch, and hopefully into the other side. You need to make sure that this doesn't happen and that it goes all the way through into the body over here. All right, and then just kind of push down on this, make sure that nothing is wobbling or cracking. Looks good. Then we're going to take the small 112 O-ring. You're going to put it right here into the little crevice around the hole that the air will actually be coming out of. This is actually to create a seal with the shell when the shell is pushed up against it by the carrier. And now, magnets. You will need 6 magnets, and they will stick to everything on your table. And what we're going to be doing is putting them into these 3 slots on the body and these 3 slots on the shell carrier. And the only thing that's important here is that the magnets on either part have to have the same polarity as every other magnet in that piece and opposite polarity of the magnets in the other piece. So what I'm going to do is take a Sharpie, and I'm going to take a magnet and make sure that it's repelling, and then I'm going to mark the backside. And then I will drop my magnets on the floor, and they will stick to every little particle of aluminum and steel shaving that is down there. Alright, so now that I have 3, I'm going to be putting the marker side down into the body. So I'm going to start with this one in the back, and then move on to the front. I had to smooth these holes out a little bit with a rotary tool to make sure that these actually fit properly. If they are loose at all, just put a dab of super glue or something in here to hold them on. Remember, these magnets are going to be repelling each other, not attracting each other, so you don't need to like overcome the magnetism of the magnet or anything. You just have to kind of physically hold it in place. And then same thing here. I'm going to mark my negatives and slot them into the carrier. Working with magnets sucks. And then we're going to take our shell carrier and we're going to push it into here, holding the catch down a little bit so we can get it in there. And we're going to want to hold it in place and put a finishing nail down through here. And I'm going to use another nail to make sure that this gets down far enough because the joint is right here. Alright, so it should kind of slide out like this. The magnetic force will push it away. And if you push it down, it should snap back into the catch. And if you apply enough force to the catch, it should open. I might need to sand that down a bit. Also, the paint is coming off on my hands, so that's exciting. Next, we need to heat up our hot glue gun. And while the glue gun heats up, what we're going to do is this little rim in here, where the plunger tube is going to meet the body, we're going to be putting hot glue in this little rim here, so that when we push the grip in, it creates a seal between the top of the tube and the body. Alternatively, you can get an O-ring in there. I'm not sure what size that would be because hot glue is readily attainable, but that is an option as well. All right, so I'm going to try to work quickly on this. Hot glue does dry quickly. I'm actually going to put some on the tube as well, on the back side where the seal is not as strong. And then quickly, at an angle, slide these two pieces together, and hopefully that made a seal. Next, take your absurdly long bolt, and we're going to slide it down through the plunger tube. Just like that. Then you're going to take this little hex key that I have heavily sanded because I had a lot of friction issues, and make sure that the hole lines up with the hole on the plunger, and just slide that down on top of the bolt, and slide a finishing nail in there to lock it in place. Also make sure that you forget to unplug your hot glue gun, that way it oozes glue all over your desk. It's very important. And then I'm going to take some super glue and glue this little piece of foam on top. Then take your large O-ring and slide it like so. If you need to increase the seal, you can slide some Teflon tape into this groove and then put your O-ring on top. This is already a tight fit for me, so I'm not going to do that. I will, however, put some lubricant on this. Then take our two threaded rods and thread an acorn nut onto the top of each. And then we're going to take this piece, slide it on top. And we're going to slide that all the way down, make sure that it aligns with this, and push it in place. Then we're going to take our spring, like so, and we're going to take this bottom plate, and you want this little notch to be facing the plunger head. Then you're going to take one of the 1/4 nuts and slide it on there. And I'm going to actually compress this a bit so that I can make enough space to slide the T-pull on and get a nut on the end here that doesn't extend too far. And then I'm going to take this nut and slide it back up. And then I'm going to tighten that, trying to keep the T-pull sort of parallel to this. Now we're going to slide the plunger into here, so make sure you keep this notch lined up with that groove, and you have to pull the trigger slightly to release the catch so that the plunger can get past it. And I'm actually going to temporarily rotate this out of the way. And then take your 6 30-second acorn nuts and put them on the other side to lock everything into place. And just make sure to get that nice and tight. And then I'm going to rotate my T-pull back into place because I want it like this. So now, as a quick test, if you pull your trigger all the way, now we're almost done just throwing on some aesthetic bits. We're going to take one of the 440 screws that's about 1/4 inch long, and we're going to use it to screw the trigger guard onto this flat part of the bottom plate. And then I'm going to take those 2 bits of music wire that I talked about earlier, and then I'm going to take the 2 little bits of music wire and slide them into the 2 holes in the trigger guard. And then we are going to align that with these 2 holes here, and then hold our plate into place and take the 1/8 inch 440s and screw them into this plate. And just get that nice and tight. Perfect. And then we're going to take our last 2 of the 1/4 inch screws, and by process of elimination, they go into the tack rail. So I'm going to pre-thread these a bit. And note that this rail is completely symmetrical, so you can put it on in any orientation and it's just peachy. I do not anticipate putting a sight of any kind on this, since it's more of a sidearm, but if I were going to, I might use a little bit longer of a screw to make sure that this grips in there enough. And assembly complete. And that's about it. I did have some difficulties retaining the finishing nail in the grip and the finishing nail in the catch. So ultimately, I ended up replacing the catch pin with a length of music wire, because it's roughly the same diameter as a finishing nail. However, my nails might just be a little bit short. I also needed to cut about 2 coils off of my spring because the prime was incredibly difficult and it made the trigger pull absolutely impossible. What was happening is each time I pulled the trigger, it was actually ejecting the shell before the catch released. So it would eject the shell and then fire, which is 100% not what you need a blaster to do. And if you have any questions about the breaking wind, feel free to leave them in the comments down below. I will leave a detailed list of all the hardware that I used in the description box below, as well as a link to the Etsy page for the breaking wind if you want to purchase the files for yourself. At the time of making this video, I don't know of any storefronts that are actually selling these, either assembled or in kit form. I know that CYardNerf is currently selling a few of their breaking wind blasters in order to help raise capital to go down that direction and, be able to amass the hardware needed to produce kits. But I think right now you just have to build it yourself. And if you enjoyed this build guide, please leave a like and feel free to subscribe if you're interested in more content like this in the future, as well as my thoughts on the breaking wind once I've put it through its paces. Thank you for watching, and I'll see you next week.